This one should be review. This particular one I would definitely do chain. I would do this, move it up and do chain rule with product rule. The times that I normally will do quotient rule is obviously if there's a square root on the bottom, because then when you square the bottom, it goes away. Quotient rule, right? Or if there's no radical at all in the denominator, a lot of times I will just leave it down there and do quotient. But this one I would definitely rewrite it. To the what power? Negative 1/3. There we go. Because here's a 1, there's the 3. I heard a lot of answers, so I waited until somebody was very definite. Let's put it this way, I heard way too many answers for that one. Now, product rule, and again, if you want to mark them as U's and V's, that's completely up to you. And so you got to take the derivative of the left side, which is pretty simple. It's almost saying what you're going to do next. And now we got to take the derivative of the right side then. And so probably a lot of times we do this because we know that second part's going to be the harder one anyway, so let's get it out of the way, right? And so I can look ahead and know that's going to be a little bit more complicated. That's when I go to those brackets because I know this is going to take some work. And so you have to do inside this product rule, we have to do for just V prime, we have to do chain. So I took that negative 1/3 times kind of that understood 1 right there, right? And what should I write next? Yeah, the exponent, which is negative 4/3, right? And then 2x. And 2x came from where? Derivative of the inside. Or if you like that f of g of x kind of thing, that was the derivative of g of x for that inside. This negative 1/3 and the negative 4/3 was kind of the derivative of the f. And don't get lost. We are just in product rule. It just happened that chain rule popped up. And so plus. And I think we can all agree that this one's going to be a little easier. We can write that one down. Yeah, 1, right? It's the derivative of the view, which is just 1. So how are we at so far? We good? Okay. Again, it's been a weekend. Maybe we have forgotten some things. Now it is okay at this point to write things all nice, get a common denominator, and do it that way. It takes forever to do that. And so this is where I really want you to get good at this next little maneuver, because it's going to happen a lot. And that is factoring out the smaller of the two, because we know we have an x squared plus 4 to some power in both of them. Right here and right there. This one, the first one, the one on the left, is negative 4/3 power, and the one on the right is negative 1/3 power. Which is the smaller of the two? Which is the one I can actually factor out? Negative 4/3. And I'm going to factor it out of both terms. Again, keep in mind that there really are two terms here. Here's one term. There's a second term, correct? And I'm going with wavy lines so it doesn't look like I'm trying to divide here. All right. And I hope you agree that then all of this, if I divide that part I just put a box around by this that I'm factoring out, what do I get? 1, right? So in other words, that's pretty much gone, right? And can I now take that times that times that? Sure. And if you want to write it out piece by piece, that's still fine too. Or I like to just multiply it together at this point. I think we're all, if you're in calculus, you're at the point that I think you should look at x, negative 1/3 and 2x, and be able to multiply that together without too much difficulty. It's obviously negative. 2/3 x squared, right? Yeah, we should all be able to do that, right? The tricky part is realizing now this first term is done, right? If I multiply out that first term, or if I just take this negative 2/3 x squared times this out here, I get the same thing, right? So I factored it out, same thing, we're good. And so the next thing I should probably write down in this brackets is a plus, yeah, because of this one right here. I'm done with that first term, we're moving on. But the difficulty is, for some of you, that right there. I haven't really factored all of that out. I factored some of it. I basically still have, I guess you could say, one of them left, right? Because the difference between those two exponents is 1, and when you divide, you subtract exponents, right? And so the difference is 1, and so we're really left with, and some people like to keep the parenthesis on there just in case it is like something else. But let's face it, it's always going to be what in this type of problem? That exponent's always going to be 1 in these types of problems. And is there anything else that I have to multiply from that second term? I can multiply it times 1 if you want, this one right here, but you don't have to. And so then you can close off brackets. Any questions where I've gone so far with this problem? Any suggestions for what to do next? Clean up the inside? Yeah, we can do that, right? Well, what do we got here? Do we really need these parentheses that I have on here with the x squared plus 4? Not really, right? So we've got a negative 2/3 x squared and a positive x squared, and there's one of them, right? So what are we really looking at there? We're looking at 1/3, right? X squared plus 4, right? What's that? I took negative 2/3 x squared plus 1 x squared. We got 1/3 x squared. How come just that's not the answer? Because we still have all of that. Now, why'd you call that the bottom? Well, yeah, it's a negative exponent, right? And so here's where I normally like to put the radical back on. And there's actually a lot you could do with that. Some of those can come out, right? Some of those can actually find their way out and all that good stuff. And you know what? If you leave it like this, that's fine. I can guarantee that's not how the book's going to leave it. Yeah. Well, that's the tricky part about this one. The question was, doesn't the 3 of the 1/3 go on the bottom? It could, but there's no 3 on this term on the bottom. It's not multiplied by that. So what would happen is this would be the book's answer. And one skill that you're going to need is be able to get to the book's answer, because a lot of times you're not going to have somebody there that's going to be able to tell you where the answer came from. Okay, and sometimes I'll be honest, some of the TAs in college are worthless. And believe it or not, those two are equivalent. And I guarantee the book's answer would be the one on the right, the x squared plus 12. So where'd it come from? Did they just make it up? What's that? Okay, so we got the 3 on the bottom. That's a definite difference as well, isn't it? So what they basically did is they got a common denominator. They made that x squared over 3 plus, excuse me, what over 3 would actually give you 4? Well, so then is it really 1/3 times all of it? Like that? Then can the 3 go on the bottom? Then it can. Okay. And so watch out for that and kind of learn how to manipulate things or be able to see where things came from. That's going to be hugely helpful. One of the other reasons I gave you that answer key to see if you could work your way through. You know, do I have the right answer? Do I not? Especially, which one was that? 35 or whatever that thing was? That was just brutal. But there you go. That's good enough, right? Good review. All right. So now for the chain rule that we're most concerned with today. And that is trigonometry. It really is just the chain rule, but I kind of say it has its own chain rule because it seems easier for people to remember. Basically, for those of you that like doing it the other way, for those of you who remember that f of x, g of x thing we did that one day, I think that very first day, some of you like to see it that way. Basically, f of x here is sine of x. Can anybody tell what g of x is? 2x, very good. So they took this 2x and they threw it in there, right? Basically what they did. And they threw it into, what do we call that? What did I call that a lot in advanced math? That 2x is the, no. It does start with a though, very simple though, not quite amplitude. Amplitude is the number that came up front. Just the angle. I'm not looking for period or phase shift or anything like that. Isn't 2x the angle that we're talking about here? It's sine of 2x, so 2x is the angle. And so trig has its own little chain rule, but it is really the same chain rule. And that chain rule kind of says take the derivative of that first piece, right? Well, the first piece here is really sine, right? It's sine of x. And so what is the derivative of sine? It's cosine, right? But the problem is I don't just have x. I have 2x. So that 2x kind of is the g of x, right? So that's the part that you leave alone, right? You just leave it. But then what does chain rule say to do? What haven't I taken the derivative of yet, technically? That g of x, I haven't taken the derivative, or the inside, right? Can you take the derivative of 2x? And what is it? 2. So you could say, some people say it like this, times 2, but I'm not really taking cosine of that, so where can I put the 2 if I wish? Out front. Okay, so do you see how it is really just the exact same chain rule we've done before, except some people like to hear it as Trig's chain rule. So basically what we did is we took the derivative of the trig, we left the angle, then we took the derivative of the angle, if you want to say it that way. And that's only if this is really the setup, that they put one function in another. That doesn't always happen. Yes? Which one? Oh, for this you take, the chain rule here for trig is kind of take the derivative of the trig, leave the angle, and then what? Derivative of the angle, there you go. Very good. Everybody ready? All right. So again, do you want to see the f of x and g of x again, or do you kind of have that, or because f of x here's cosine of x, g of x is x minus 1, right? So obviously you start by taking the derivative of the left side, which is just y prime. That's easy. So according to Trig's chain rule, what should I do? Derivative of cosine, which is negative sine. Very good. Sounds as though you've taken my warning to heart there and you've memorized those two, at least gotten close, right? And then what? Yeah, leave the what? Leave the angle. Right? Just leave it. And then derivative of what? The angle, which is 1, right? Sometimes I tell people to write it just so if you look back at this problem, you realize you actually have finished the problem and don't think, oh, I forgot something, okay? And so the derivative, is simply written, is just that. Yes? The 1? Sure. Yep. But don't put, well, be careful. Don't put the 1, for example, here. That's different. 1 minus sign is, right? That's times 1. So be careful where you put it. But say that again. Well, you can put it here if you want. Just don't put it out in front of the negative, because then it's 1 minus. No, not really. Just don't change the answer. You know what I mean? Have it still mean the same thing. If you put the 1 out in front of the negative, then it's not the same thing as it was before. Okay. So any questions in general on that? All right, these next 3 examples, take a look at them. I truly believe if you can keep these next 3 straight, you won't have any trouble with trig. Do you see how they are basically very, very close to the same problem? This first one here says cosine of 3 times x squared, correct? So my question to you, do I need chain rule? No, you don't. What is cosine of 3, basically? Is that something we could calculate? The cosine of 3? So do you agree that's just some number? So in other words, that's just a coefficient? So what if I gave you this problem, instead of cosine of 3x squared, I said 2x squared? Would you need chain rule for that? For 2x squared, you would need chain rule? Wouldn't that just be power rule? Good thing I missed the mic with that. All right. That right there is a number. So if I gave you this problem, you'd use chain rule on that? No. So you don't need it here either. There's no function inside another function. So how did we do these? If this right there is just a number, how do you take the derivative with power rule? Yeah, 2 times that, right? You bring the exponent, take it times that. So what's 2 times that? Well, it's that, isn't it? Some number. And then when you do power rule, what are you supposed to do? You write the variable, and then do what with the exponent? Take it down to power, so 1. So there you go. There's your derivative. But make sure you don't write like that, because have I just changed the problem? Yeah, that could mean something different to everybody, right? So you really have to make sure that you go like that and say it's this number times x. Because technically the graph of that one, the original, is just a parabola. The coefficient is just cosine of 3, whatever that decimal is. So is the answer to the next one going to be the same? How's this one different? What's that? Yeah, 3 is not part of the cosine anymore. So are we talking about cosine of 3, that number again? No. And what's technically being squared? The angle. Just the angle. If the whole thing was being squared, what would I have to do? Do that, right? So the only thing getting squared is the angle. Is that something we can do? Is that something we can calculate? It is, isn't it? So we could rewrite this as what? I'm just rewriting. Notice there's no prime, no derivative. Actually take the angle and square it. So 9x squared, right? Right. All we had to do is square the angle, and so we did. Well, we need chain rule. I heard a couple no's. I heard a couple yeses. Is there a function put inside some other function? Yeah, cosine of x is our main function, and what function got thrown into it? 9x squared, right? So yes, we do. And this is basically Trigg's chain rule, right? Which tells you to do what? Take the derivative of the cosine, so negative sine. Yeah, leave it. I heard somebody say it, yeah, 18x. Now, once again, when you have sign involved here, when that negative's out front, let's put it that way, and most times this can be sign. But when there's a negative out front, you have to be very careful where you rearrange things. 9x squared is still the angle, correct? I can't really move that then, because I'm taking sine of that angle. It's some kind of function. But the 18x can be moved, but you have to be very careful where you move it. Because that's something you can or can't do to have it still mean the same thing. Can I do that? Yeah, it's all multiplied together. I can do that. Again, putting the 18, say, out there. 18 minus that? No, not the same thing. Yes? Okay. The reason that we did that is it was going to make that next derivative easier. That's the reason I squared the angle. Because had we not done that, it would have come out the same, but we would have needed a second chain rule to do that part. That you can actually, with the trig, if you can actually square the angle, probably square it. Or even if you can take it to the third power, if it's something like that, if it's a monomial that you can square, square. It's going to make life easier. Yes? Right here, this middle one? Technically, you can leave it that way unless you feel you're going to get confused and think the 18x is part of the angle. That's one of the main reasons I move it. Or at least show you that you can move it so that you don't think it's part of the angle. Okay. And the last one looks almost the same thing, except now. So how did we rewrite this in advanced math? That's truly how this probably should be written, and it's just that we're lazy and we don't. That's probably how it should be written. It's basically the whole thing squared. That's always what this means. Whatever power they put there, it's really saying take the whole thing to that power. But let's face it, that's much more streamlined than the other version over there. Suggestions? Yeah. Chain rule inside of chain rule. You could do it the other way, I suppose. You could just do this product rule, but that'd just be long and annoying. All right. So the 2 comes out front. This is the normal chain rule. And then, as we were told, you write down what's inside, right? So this is basically a function inside a function inside a function. So lots of fun. It's 3x inside of cosine of x inside x squared. Yes. And we were told to bring this down a power, so what would go here? 1, right? Now we're going to go and take the derivative of the inside. But the inside is cosine of 3x, which is something you need the chain rule for all on itself. And what does that chain rule tell you to do? Again, just stop yourself for a second and say, if I was given cosine of 3x, what would I do? Negative sign, very good. You would take the derivative of the trig, write down the angle, right? And then what? Derivative of the 3x, which is 3. Sometimes you really have to remove yourself from the problem and say, if this was all I was given, what would I do? Okay, so do you see the chain rule inside a chain rule? Yeah, it's really weird, but it does happen. Now, here is where the algebra can save you, and make sure you do it right, though. That's just the worst F prime ever, but it looks like some other language, and doesn't it? I don't know. Yeah, I don't know. What can you do and what can't you do? The fact that this is a 1 opens up a huge possibility. If it was something else, you're kind of narrowed in your scope of what you can do. Can I, for example, you agree there's a -1 here? And there's a 3 there. And there's a 2 here. Can all of those be multiplied together? Yeah. So it's -1 times 3 times 2, -6. Is there any need for any powers on that cosine of 3x? Because really what's understood, you've probably never thought of it this way, but what's really understood to be here? Oh, 1, right? And? There it is. Yep, that's it. Yes. Because it's all multiplication. In a way, yeah, it's combining like terms. But be careful. As everybody understands that this problem's done, I'm going to go change something. Okay. Let's say you were going along and there happened to be one of those up there. And maybe there happened to be a 2 or something in here. Well, then you have to be careful. Is it really just 2 times negative 1 times 3? Not really. It's really 2 times 8 for this 2. Because this 2 is cubed. Okay, and then here you would also have that, you see. So you have to be a little careful. But the fact that that's first power, that's not always going to be first power. Because obviously we could have started somewhere else up here. But just be careful. Don't just think it's a 2. Watch out for those exponents, I guess, would be my biggest suggestion. I would say make sure that you know the difference between these last 3 examples. If you do, you're off to a really good start. Are there any more questions? You've had some really good ones today.